Student t-test for paired or unpaired samples in R statistics. Student t-test for paired or related or dependent samples in R statistics. T-test is a parametric test, and the paired t-test is performed when there are two sets of data, and the aim is to find out whether there is a difference between these two sets of data. There are certain assumptions that have to be fulfilled before using the paired t-test. The first assumption is that the data within the two samples are continuous and the data are normally distributed, and the difference between the paired samples is normally distributed, and this difference or approximately normally distributed, and the difference doesn't have an outliers in it. So to perform the test, these conditions or criteria have to be fulfilled. To perform the analysis for paired t-test in R, launch the RStudio and then set the working directory for the files that have the data in it. So by clicking on session, then scroll down to set working directory and then click on choose directory. Select the folder that contains the data, which is R here. Click on open. The directory is set as shown here. The next step is to load the tidyverse library by typing library, open a bracket, tidyverse, and then select the tidyverse package. If the tidyverse package is not installed, then search at the help center here and then type tidyverse, and the software will show you how to install the package for tidyverse. The next step is to load the data or the files that contains the data that we need to do paired t-test on it by using the read underscore table command. Give this table a name, call it X, then use the assignment operator. Type in the read underscore table command as the data is saved in a text format. Between the two brackets, insert a two quotation mark and then type the name of the file, which is called systolic blood pressure .txt, and then hit enter. As shown here, the data file is loaded into R, and two variables or data in it. One is called systolic blood pressure and the other one is treatment. Treatment is character and the systolic blood pressure is a scale or continuous data. Let's view the data by typing view, open a bracket, insert X, hit enter, and as shown here in this section, two variables. The first one shows the systolic blood pressure for participant, and the second variable is called treatment, as there are two conditions, untreated and treated, and these data are paired. So the same participant has been first the systolic blood pressure measured before treatment, and then post treatment the systolic blood pressure again measured on the participant. So the participant had participated in the two conditions: a condition with the first condition when there was no treatment, and the condition when there was a treatment. So the objective is to look at if there is a difference between the drug taking compared to untaking the drug, and whether the drug for treating systolic blood pressure can lower the systolic blood pressure. And the way to do the analysis is to use the paired t-test, as the data here are paired and each participant participated twice in this study. If I type only X, if I scroll down here and type X, and as shown here, it shows a structure of a table which has a data in it which is continuous, and a character which is the treatment, treated or untreated, and there are 50 participants. To do the paired t-test and to find out whether there is a difference between taking the drug compared to untreated, then the paired t-test will be performed. And the way to do that is to type t.test, open a bracket, and then type data equal to the name of the data, which is X, and then type the dependent variable, which is the systolic blood pressure, and then use the title symbol and use the grouping variable, which is treatment, and then comma. And since we are doing here a paired t-test, then we need to type paired equal to true for t and hit enter. An outcome is generated from the RStudio showing that this test is paired t-test, and the data are systolic blood pressure grouped by treatment, whether there is a treated or not treated, and a t value is generated which is minus 3.7 and a degree of freedom 49 and a p value of less than 0.05. And as shown here, the mean difference between these two set of data or two groups, treated and untreated, the value is minus 8.1, which means that the drug had lowered the systolic blood pressure in the group that taken the drug compared to the same group that were not at time 0, where there was no drug administered. So this data shows, or this data analysis shows, that the drug lowered the systolic blood pressure, and this lowering is significant as the p-value is less than 0.05. And also a 95% confident interval is generated here for the mean difference. And as shown here, that the mean difference is between these two values, the upper and the lower, for the 95% confident interval. This will add a layer of assuring that there is a statistical significant differences between taking the drug compared to untreated. Student t-test for independent samples or unpaired samples in R statistics. Student t-test is a parametric test that can be performed when there are two groups of data, and these two groups have scores in it that are normally distributed. So the data has to be normally distributed to use this parametric test. And the objective of using this test is to find out whether there is a difference between these two groups. Launch the R Studio and then click on Sessions and set the working directory. I'm going to set the directory where I have the data for the t-test. Click on Open, and as shown here, the working directory is set at this folder, which has the data that we need to do t-test. To the analysis, first we need to load the tidyverse library. If you have not installed the tidyverse package, then install that freely from the R Studio. So to load the tidyverse, type library and then open a bracket, type tidyverse and select the tidyverse and hit enter. The package will be loaded into R and it is now ready to be used. To load the data into R, give it a name which is H, stands for the height, then the assignment operator, and then use the command which is read underscore CSV, hit enter, and then between the two bracket insert two quotation mark and then type the name of the file, which is gender, which is already in the directory for statistics, and the file name is gender underscore height dot CSV. Click enter. The data is loaded into R and it has two columns. The first one is character, which is the gender, and the second one is the height, which is continuous variable. To view the data, type view, open a bracket and insert H, hit enter. A table is generated showing that there are 100 scores and there are two variables. The first variable is a gender, female and male, two groups, and the second variable is a continuous variable, which is the height of each individual measured in centimeter. So the height is the dependent or the outcome variable, and the gender is the independent or the predictor variable. To test whether there is a difference in the height between males and females, then t-test for unpaired or independent samples will be used, as here we have two separate groups, male and females, so the data are independent or not related or unpaired. And to find out whether there is a difference between males and females in comparison to the height, then we will use the t-test, and to do the t-test, certain assumptions has to be or have to be fulfilled. We're not going to discuss it here, but we'll show you how to do the command for the t-test. In this section here, type t.test, open a bracket, then type data and the name of the data, which is H for height, and then comma, insert first the label or the name of the variable, which is the dependent one, which is height, and then use the title symbol and the predictor or the independent variable, which is the gender. Close the bracket and hit enter. An outcome is generated showing two sample t-test, as the data here is the height segregated or separated by the gender grouping, which is male and female, and a statistical t-test value is given here minus 3.1, degree of freedom, and a p-value of less than 0.05, which means that there is a significant difference between males and females. As shown here, the mean for the female is 160 centimeter and the mean for the male group is 173.7. So this test has proved that there is a significant difference between the two classes of individuals. Also, given with this output for the analysis, a 95% confidence interval as shown here.